Good evening, everyone. Welcome to this tutorial lecture on discrete mathematics. This week, we'll be discussing week 3 assignments from previous iteration of this course, and it would be on logic and propositions mostly. So I'll be sharing my screen. So someone just confirm when the screen is visible. Uh, uh, I hope you can see the screen. Can everyone see the screen? Okay, so let's get started. So coming to question one. So which of the following sentences is or are a statement? So you have four options. So first is bring some water. So bring some water. This statement is an order. So this is an imperative sentence. Second one is how was your day? So this is a question. This is interrogative. Third one, Mount Everest is the tallest mountain on earth. So this is an assertive sentence. Right? It is a fact. This is an assertive sentence. And fourth one, that's a terrific performance. This is an exclamation. So this is an exclamatory sentence. Now, of all the four types of sentences, assertive sentence are what is known as uh, statements. So the right answer for this question is C. So just a stating of a fact is a statement. Others are not statements. They are different kinds of sentences. I hope this is clear. All right. So we'll be moving on to the next question. So which of the following is or are true? So you have four uh, equivalence logical equivalence relationships given, and we are asked to say which of the following is true. So w- can anyone from the chat in the right in the chat box which do they think are true? Right. You can unmute yourself and say as well which of the four equivalence
Sir,
relation. Yeah,
I
go ahead.
think A, B, and D are correct.
Can you repeat once again?
Yes, sir. A, B, and D.
A, B, and D. Okay, so okay, let us check A, B, and D. So can you give your reasoning why A, B, and D are correct? Like
Yes, sir.
for
By Venn diagram.
okay, so let me draw the Venn diagram. Okay, so suppose this is P, this is Q, and this is R. Let's say P, uh, Q, and R. So if you say option A is correct, so which means that P or Q would be the union of P and Q, and P or Q, and or R would be the union of all three, right? So let me so it would be, let us say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So uh, the left hand side of A is LHS is 1 plus 2 plus 3 plus 4 plus 5 plus 6. Yeah. Okay. So, and the RHS is again the same. So, R or Q would be the union of R and Q. And if you do OR with P, it would be again the same thing. So, A is correct, as you say, by Venn diagram. Can you say about B, how B is correct? Uh, can someone say why B? Whoever mentioned that A, B, and D are correct. So can you explain why B is correct? Uh, you can unmute yourself and say, or you can write in the chat box as well. Okay, so I'll say why. If we look at B, so if we take the left hand side of B, so for option B, LHS is not of P intersection P and Q or R. So this part, this not of P and Q, we can use De Morgan's theorem and rewrite it as not of P or not of Q and whole or with R. So so the OR operator, so we have two OR operators, and by associative law, you can take OR, like you can change the braces as well, and you can, they are commutative as well. So this can be written as R or not P or not Q by um, associative and commutative property of OR operator. Therefore, you see this is the RHS. So this way we can say that B is also correct. Now someone had said D. So uh, okay, so can someone whoever mentioned that why C or D? Do you think C or D are correct? This is the first question.
No, sir, C and D are false.
Why can you explain?
यस सर सर डी तो एसोसिएटिव प्रॉपर्टी ही है.
Uh,
हमने बस इसका यूनियन उठा के वहां पे लगा दिया तो वो इक्वल होता है, इन्होंने नॉट इक्वल कहा है तो डी
uh,
तो इसलिए फॉल्स हो जाएगा.
right, you're right. So
और सर सी में जब सर हम एलएचएस को खोलेंगे तो ये बनेगा नेगेशन पी यूनियन नेगेशन क्यू यूनियन आर.
okay, right. So if you see B
पर
and
हम
C, yeah, go ahead.
तो इसीलिए रॉन्ग हो जाए. हाँ जी
Yeah,
सर.
yeah. So if you see B and C, they the left hand side are the same, but the right hand side are different. So you have R over here and negation of R over here. So that's why if B is correct, C cannot be correct. So C is wrong. So A and B are the right answers for this question. You're right. So let us move on to the next question. So we have uh, two sentences. Consider two sentences. So when it is Sunday, paneer is served in the mess. Paneer was served in the mess today. So what can you definitely conclude? So this one, the second one is a statement, and the first one is a conditional statement. Now, okay, so can anyone say what do you think can we definitely conclude? What is the right answer among A, B, and C?
Option C, sir. I think.
Uh, Okay, so can you explain how do you think option C is correct?
Sir, when the statement when it is Sunday, that is an hypothesis. So it may or may not be true, but the condition might or might not depend on the hypothesis. So that's why.
Okay, you are right. So I'll explain it a little for everyone else. So if you see statement one, we call this as statement one and statement two. So statement one says that when it is Sunday, paneer is served in the mess. And second statement says paneer was served in the mess. So it statement one means that whenever it is Sunday, whenever it is Sunday, paneer will always be served. But this, but when it is not Sunday, when it is not Sunday, paneer may or may not be served. So the picture looks like this. So if I draw the Venn diagram, so this is, let's say, Sunday. So this circle represents Sunday. And it is said that whenever it is Sunday, paneer will always be served, and when it is not Sunday, paneer may or may not be. It means that the set that paneer is served, this set is a superset of the set Sunday. So this set represents paneer is served. Now they are saying, if you look at statement 2, paneer was served in the mess today, means you were somewhere in this red set. So it can be that your point lies within this Sunday, or it can lie outside this Sunday as well. So the right, so we cannot definitely conclude whether it is Sunday or not. So the right answer for this question is option C. So today may or may not be a Sunday. I hope that is clear to everyone, or if anyone has a different explanation, they can also go ahead and say. Okay, then.
Uh, so
Yeah,
we
go
can use
ahead.
truth table also, right?
Uh,
I mean, this is A implies B. So
yeah, yeah.
according to truth, yeah.
Uh, so, like you said, so uh, if it is Sunday, so let's call this part as S, and paneer is served in the mess. This part is P. So basically, statement one is S implies P. and statement 2 says that P is true, but s- if P is true, it need not be that S is true as well. So if S is true, then P is true, but P being if P is true need not imply that S is true. So um, therefore P, so you can think of it like this, that P is a necessary condition. P is a necessary condition for S, but not a sufficient. So S may or may not be true. Therefore, option C, it may or may not be a Sunday. Right. Anything else anyone wants to add?
Excuse me, sir.
Yeah, go ahead.
So tomorrow I am having the session of problem solving in C at the
Uh,
same time 6 to 8, and session is also at the same time 6 to 8. So can I have the recording of this session?
yeah, you can, like, it will be uploaded in that course web page. You can check it out.
Okay, sir. Thank you, sir.
Yeah, yeah, no problem. Okay. So we can move on to the next question. So now we come to another statement. So it has not happened that Rohit did not complete his homework. So which of the following can you infer? So you have four statements. Rohit completes his homework always. Rohit never completes his homework. Rohit has completed his homework just once. Once Rohit had not completed his homework. So can anyone tell which of the options is correct from A, B, C, D? Can anyone go ahead and say? Anyone? Oh, all right. So I'll go ahead with the solution. So you see this statement, it has not happened. So it has not yet happened, one part, and Rohit did not complete his homework. Let R, the statement R be Rohit completes homework. Rohit did not complete his homework is R bar. And if you see Rohit did not complete his homework is so this statement is basically this part is R bar, and then it is saying that not yet happened. So if you take a negation, so basically negation is like not of R, and you take another negation. So double negation would basically be the same thing. So Rohit completes his homework. So basically it means that option A, Rohit has always completed his homework. You can think of this problem like this also. Another interpretation. So you have this Venn diagram. So set. So let uh, R be the set in which Rohit completes his homework, and this cross represents the instances when he does not complete his homework. It is said that it has never happened, that there is no instance of this cross. So there are no no elements outside R. So which implies that all elements are inside R. So therefore, it means that at all observed instances, Rohit has completed his homework. So that is one another way of thinking as well. So anyone has a any question regarding this solution or any different approach, you can go ahead. Uh, all right. Let us move on to the next question. So you have considered the given statements to be true. So you have three statements. One is P implies Q, Q implies R, and P or R, this is true. So this these two are conditional statements. The third one is a statement. So can anyone say what can you definitely conclude from this, that whether not Q is true, that is Q is false, B whether Q is true, or C P and R is true, or it is an insufficient information? So can anyone go ahead and say? You can write in the chat box as well. Am I audible to you guys? Or eh,
Yes, sir, you are audible.
yeah, so what do you think would be the answer to this question?
I think, sir, B. Q will always be true.
Can you explain how you concluded that?
Sir. Yes, sir, because in the first statement it is given P implies Q. P implies Q means negation P union Q. It is true. And in next
Right.
it is given negation R union Q. It is, and in the last it is given P union R. It is true. So if P and R they both are true, then negation P will become false. And false union false is always false. So false union true can only be true. So Q must be true.
Uh, Okay, you're right. So I'll explain it once again for everyone. So, like Aditi said, that so we'll first look, before looking at this conditional statement, these implications, we'll look at this normal statement, that P or R. So this can be, when do you think that P or R is true? So which instances do you think P or R can be true? Can anyone say when P, this statement will be true, P or R?
When either of them or both of them are true.
Right, very well. So it means that either P or R or both are true. Now, if we go back to this implications, now it says that P implies Q. So if it happens that if P is true, what do you think will happen? What will, if P is true, what do you think will happen to Q? Can anyone say what, if we assume that this statement is right, that P implies Q, and if P is true, what do you think, whether Q is false or true?
Q is
Q will be
true.
true.
Right. So if P is true, Q is definitely true. And if R is true, what do you think will happen to Q? Again, it is definitely true. So Q is again definitely true. Now come to the third question. It says that at least one of them will be true. So P or R or both are true to be so that P or R is true. Therefore, either of these two statements will have to hold. That is either P is true or R is true or both. Therefore, Q is definitely true. So therefore, option B is the right answer for this question. That Q is you can we can conclude that q will always be true for this case. So does anyone have a problem, any doubt regarding this explanation, or do you have any other explanation? You can go ahead. All right, so we'll be moving on to the next question. Again, we have some statements that are given. So we have negation of p and q is true. R implies p, negation of R implies S, and S implies T. So these three are implications. The first one is a statement. So which of the following is true or false? So can anyone take a guess which of the following would be true or false? Okay, so let us first break it down step by step. So come to the first statement. So and P and so negation of P and Q. So when do you think that the AND operator is true? If you have given two logical variables, when do you think that the AND operator will give true as the output?
Both should be true.
The option A and option C are correct.
Okay, so you're right. Option A and C are correct. So we'll come to that. So yeah, so like someone said that both of them should be true. It means that negation of P is true. Since this statement is true, from here we can definitely conclude that both negation of P and Q have to be true. Negation of P is true and Q is true. Now, if negation of P is true, it means that P is false, right? Okay. Now come to the second implication that R implies P. So R implies P is basically like this. If I draw the diagram, so Venn diagram. So R implies P is we have a smaller set and a larger set. So R is the subset of P. Now, can anyone tell that if R is false, sorry, if P is false, what will happen to R? Can anyone go ahead and tell?
R must be true.
So now I am saying that P is false. So see, if R is true, P is definitely true. But if P is false, means see, you are outside this set. So you are in this dotted region. What do you think? So true is when you are inside the set and dotted region is outside the set. So you see that this dotted region is outside the set R as well, right? So if P is false, R is definitely false. Is this clear why R is false?
Yes, sir.
Uh, okay.
Yes, sir.
Now come to the third statement. So it says that if R is false, then S is true, which means that now we know from the two statements above that R is definitely false. Therefore, this statement would say that S is definitely true, right? If S is definitely true, now come to the fourth statement, that if now S implies T. If S is definitely true, with what do you think will happen to T? Whether T is true or
T
false?
should also be true, sir.
Right. So T is also definitely true. Therefore, S is also true, T is also true. So like Aditi mentioned that A and C both are correct options. I hope this is clear. And does anyone have a doubt or any other explanation? You can go ahead. All right. We'll move on to the next question. That is question number 7. So you have three logical variables P, Q, and R, and you have this P XOR Q XOR R as true. So, can anyone tell what this XOR operator does? So, if you have a variable, logical variable A, and you have another logical variable B, so when do you think what is the output of this operator? Can anyone tell?
If both the operators are true or if both are false, then the output is false. Otherwise, the output is true.
Right. So, at only if one of them is true and the other is false. So, it is false when both of them are false and both of them are true. So, I'll show this with a truth table. So if you have A, B, so you have 0, 0, 1, 1, 0, 0. So now if both of them are false, it is false. If one of them is true, then it is true. If one of them is true, it's true. If both are true, then also it is false. So this is what the XOR operator does. Now they are asking us what is the XOR operator? When will this? If you have three variables, when do you think it will be true? So can anyone tell when this for three variables, if you have an XOR, when will this be true? Can anyone take a guess?
Sir, for odd number of ones.
For odd number of ones. So yeah, so you are right. So odd number of ones means, so it means that either, so it could be odd number of uh, true variables. So it means that uh, only one of them is true or all three are true. So if only one of them is true, so it could be that either P is true or Q is true or R is true. So we have three instances over here and all three are true. That is only one instance. So total we have four instances. So the right answer is option 4. So we can check this by drawing the truth table as well. So just for completeness, I will show you using the truth table as well. So you have P, Q, R, and you have P or Q, XOR Q, and you have P, Q, XOR R. So let me write it down as 0, 0. So P XOR Q is true when only one of them is true. So the first sentence is false, false, true, 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 false, false. Now we are taking XOR of P XOR Q and R. So if we take the XOR combination and use the associative and commutative laws, we will get that uh, when, let's say, this is M. So when the variable M, either M is true or R is true, but not both. So that is how you get odd number of, when odd number of true variables are there. So the first one, 0 0, it would be 0. This one is true. This one is again true. This one is false. This one is true. This one is false, false, true. Now if you check which instances, if we check these rows, you see, so in this four cases, you see that either only one is true and here all are true. So this is how you get the four different cases. And so 3 plus 1 adds up to 4. So if anyone has a doubt regarding this question, or is, if they have a different explanation, can you can go ahead, or we will proceed on to the next question.
So formula in the chat, 2 multiplied by n plus 1 or minus 1. Sir, is this formula valid everywhere?
Which one? Can you say again?
Yes, sir. Sir, somebody has mentioned the formula in the chat that it is 2 multiplied by n minus 1, where n equal number of variables.
Wait,
Here
wait.
the variables are seen.
I can't see the chat comment somehow. Can you just type it again?
Yes, sir.
Did you type? Uh, uh, uh,
Sir, I have sent the chat.
all right. Um, Somehow it is not loading. Just give me 1 minute. I'll check.
Yes, sir.
Sir, as the variable increases, the number of different assignments depends on the power of 2. Like
Right.
suppose two variables are there, then different assignments will be 2. When there are three variables, then will be 4. So on observing this pattern, we find out that it depends on 2 raised to n minus 1, where n could be considered as a different number of assignments.
Okay, so yeah. So if it is 3, you are saying that it is 2 to the power 3 minus 1, that is 2. Yeah, you are right. So can you explain like what you just mentioned? Can you say it again? Like how did you get this 2 to the power n minus 1? So if there are n variables, so can you explain why it is coming as 2 to the power n minus 1?
Sir, I tried for some four variables and I
Uh,
observed this pattern. Like every time, like suppose on some iteration, I have some number, I have like well, suppose three variables, I have eight values. And
okay,
suppose I add another like assignment to it. So
okay,
that will have a value 0 or 1. So basically, if it's 0 or 1, in either of the cases, either it will be true or false. But we are interested in finding out the number of assignments. So basically that 2 gets multiplied every time. So like it gets exponentially added up.
Yeah, you are right. So there can be, you can think of it as uh, one more way. So if you have like this, so for if you have, let's say, n variables, and you can, and this expression that the XOR of all the variables is true happens for, let's say, for n variables, it happens for uh, tn times. And now you add the n plus 1th variable. So when, so the, these are true for tn times, and therefore this, and when you add one extra variable to it, this will be true when this tn, the uh, conditions when tn, this is true and this nth variable is false. So this will happen for when you add for tn instances, this will be false plus the rest of the term. So if you have n variables, so you will have total of uh, 2 to the power n combinations. So for the tn variables, when this is false, when the tn number of times, when for the nth variable this is true, the n, when the n plus 1th variable is false, then the XOR will be true. And for 2n minus t to the power n variable, it would uh, again be true. So for n plus 1th variable, it is 2 to the power n. So for nth variable, it would be 2 to the power. Have a doubt, you can just ask me how we are getting this. So if you anyone have a doubt, I can explain it once again. Uh,
No, sir, it is clear now.
uh, can you repeat what you said? Wait,
It is clear now.
okay. uh, that is how you get this 2 to the power n minus 1. Okay, we'll move on to the next question then. So we considered the following statement that uh, we have p, a number is a factor of 100, q, a number is a factor of 5000. So which of the following is true? So what do you think is the right answer? Can anyone take a guess? So this is okay. So a number is a factor
Sir,
of,
I
yeah, yeah, go ahead.
think option
Uh, can you so someone has written P implies Q. So option A they are saying is the right answer.
yes, sir, I think option
Uh, can you come again, Aditi? So I think your voice is breaking a bit. at least on my end, can you just, if you don't mind, can you type it in the chat box if you are having a problem? I can't hear what you said.
Option A is correct. That
Yeah,
I think option A is correct.
yeah. So, can you give your explanation? So, why do you think A is correct?
Uh, because sir, P is a subset of Q.
Right.
So
So, yeah, go
should
ahead.
be equal minus P. So if we will take it union with Q, then we will get whole Q, which will be the universal set. So P implies Q will be the true.
Yeah, you are right. So, if you see any number that is a factor of 100, so just by common sense, so 5,000 can be written as 50 into 100. So any factor of 100 will automatically be a factor of 5,000. That is true, right? So which means that factors of, let's say, we have this set P, these are the factors of 100, and the set Q would be the larger set Q, which is, so the factors of 100 are within P and the factors of 5,000 are within Q. So why do you think that it is a subset? Because any, so 5,000 can be broken down into 15 to 100, and any factor of 100 is already present in this 5,000 expression. So, but there could be factors of 5,000 which are not factors of 100. Can anyone give me an example of a factor of 5,000 which is not a factor of 100?
500.
Yeah, right. So 500 is a factor of 5,000 which is not a factor of 100. So 500 will lie somewhere over here. So this is, let's say, 500, this point, but it is outside P. So therefore P is the smaller set which is contained, wholly contained within Q, and therefore P implies Q is the right answer. Q implies P would mean that Q has to be the smaller set, which is definitely, so B is not correct. P and Q are equivalent. So is it a double implication? No, because then the sets have to be of the same side. So there are elements in. So if this held true, option C was true, it would have implied that 500 is also a factor of 100. So any factor of 100 is a factor of 5,000, and any factor of 5,000 is also a factor of 100. But that is not true. Therefore, this implication is false. And D says that negation of P implies Q. So negation of P does not imply Q, because that when negation of P is, means when P is false, that is outside of Q, does that imply that Q is true? So need not be. So negation of P could be somewhere over here, but that does not imply that Q is true. Therefore D is not true as well. So the right answer is option A. Uh, Coming to the next question. So consider a statement P, which of the following is or are a contradiction. So where this T stands for tautology. T is tautology. So it means that a statement is always true, as a true statement. Now, can anyone go ahead and tell that which of the following is or are is a contradiction? Contradiction means always false. So it is denoted by F sometimes. So can anyone tell me which of them is always false?
Option B, sir.
I think C.
You think B and C, and Krishna said option D. So let us
Yes, sir,
check.
both B and C.
Okay, so can you explain why? First, let us look at B. So can you tell why B is a contradiction? So what do you think is, if you look at inside the braces, so what do you think, P or negation of P? What do you think that will be? That is that a tautology or a contradiction, or it can be sometimes true, sometimes false? What do you think?
Tautology, sir.
Yeah, so the inside of B is a tautology, which means that negation of a tautology is a contradiction. Therefore, option B is correct. B is a contradiction. Now, can someone explain why C is a contradiction?
Yes, sir. Because, sir, now also in bracket it is tautology.
Right. So, if you see that, if you take any statement and you do a or with a tautology, it will always be true, because for an or statement, if one of them is true, the whole sentence, the whole compound statement has to be true. Therefore, since it is, you have a tautology, the compound of negation of P or T will always be true. And again, you have a negation outside, so it turns out to be a negation of a tautology, which is equivalent to a contradiction. Can you just say why A cannot be a contradiction? Because,
A is
go
always
ahead.
Because,
true.
sir, A is
Right, A is always true, and similarly D is always true, because you're taking a or with a tautology. So A and D will always be tautologies. So therefore, A and D cannot be a contradiction. So the right answer is both B and C. All right. Uh, Let us move ahead with the final question for the session. So we have again a simple statement. So T means tautology and F stands for contradiction. So what do you think? So you have this logical expression. What do you think if we simplify this terms to be? So let us look at it by part by part. So let us call, we have this one part, and you have the second part. So can anyone tell me what is this? You have the statements PQ. So what do you think? So let me ask. So what do you think of this green portion? So is it always true or always false, or sometimes true, sometimes false? What do you think?
It can take both true and false values.
Right. So it can take both true and false, because we do not know anything extra about P and Q. So we, for now, since it is not mentioned, P and Q can take both true or false value, and depending on both what P and Q can take, this green portion can take both true and false value as well. Now come to the second one. So what do you think, that you have a P and you are taking an OR with a tautology? What do you think that will be?
tautology.
Right. So you're taking an OR with a tautology, so it will definitely be a tautology. And then you have this operator OR in between. So you have an OR operator. So on the left hand side is a variable that can be either true or false. On the left hand side is a true or false. On the right hand side, it is always true. So therefore, what do you think it will be? It will always be a tautology, right? So option B is the right answer for this question. So you need not evaluate the left hand side at all. Just looking at the left hand side, you know that it would be a tautology, and if you take an OR with a tautology, it will be a tautology. So therefore, option B. So this whole statement will always be a tautology. I hope this is clear to everyone. So this brings us to the end of our discussion. So if you have any doubts or any regarding what we have discussed, or any other questions that you might want to discuss, you can go ahead. And if you have missed anything, I can repeat it if you have any doubt. Does anyone have any doubt? All right, then if no one has a doubt, then we can close the session for the day, and we can meet again next week. So there will be another session tomorrow as well. Uh, so you can attend that. We'll be discussing week 3 questions, and but it will be a little different from this session. It will be more on the theory side, and different questions would be discussed over there. You can attend that session as well, or else we'll be meeting again next Monday, same time, to discuss week 4 assignment solutions.
Okay, sir.
Yeah, yeah. Thank you everyone for taking the time to join. All the best for the course.
Thank you, sir.
Yeah.